Hi, this is Willie with the Viper team, and this is our project wrap-up video for our Catalyst Fund 8 project to extend the Cardano-Tools Python library. Cardano-Tools is a Python package that we created to enable app developers and stake pool operators to interact with the Cardano blockchain. Our tools can be used to interface applications with the Cardano node, with the Cardano command line interface, or CLI, as well as the Cardano wallet backend entirely within a Python environment. Our project consisted of 3 milestones aimed at extending this library. Our first milestone was to add wrappers for new commands that have been added to the Cardano CLI. Those are stake pool leadership slot calculations, incremental multi-signature transaction creation, and Cardano node mempool queries. So we've successfully implemented all three of those commands in our library. Our next milestone was to extend the amount of the Cardano wallet backend that is wrapped by our library. So we began the project with 12% coverage of the total wallet API commands, and we ended with 92% of the commands covered. Our goal for this milestone was to reach 85% coverage. And finally, milestone 3 was to increase the overall unit test coverage of our library. And we use that to continually verify that Cardano-Tools works properly as the underlying Cardano node and wallet backends are updated. So we began the project with 16% total unit test coverage of our library, and we ended with 50% coverage. Our goal was to reach at least 26%. So we've met all of our milestones, and for the rest of the video, I'd just like to spend a few minutes and show a demo of what we've done. First off, you can see here, here's where we host our open source Cardano Tools library. It's on GitLab, so you're welcome to clone the source code. But an easier way to work with it is you can just directly pip install Cardano Tools. So would recommend only working with the source code if you'd like to make changes. And by all means, if there are features you would like to add, please add them in and send us a merge request, and we'd love to have people collaborate. But alternatively, if you just want to run the latest release, just pip install it, and you'll have all the dependencies in the library automatically built. In our README here, we have detailed instructions on how to set up your environment and how to use the various features of our library within Python. So we will show that here live. So first off, here's our unit tests. You can run through these if you would like. If you have the source code, we use Poetry as a environment for Python. If you install Poetry, you can just simply run Poetry install within the Cardano Tools package, and that will install all the dependencies we have. I've already got that set up here, so there's nothing to install. And then you can run our PyTest unit tests. So it takes a few minutes to run. Some of the tests will actually detect if you have a local testnet node running, and if so, it will actually send transactions, join and leave a stake pool, all kinds of different things that it take a few minutes, to wait for the blockchain to sync and stuff. So I already ran that here. You can see all the files that ran through unit tests, and here is our 50% coverage. So we've covered over 2,000 statements in our library so far, and we'll continue working to get that closer to 100%. Some things are kind of hard to test, as I said, working with a live blockchain kind of make these things complex to test out effectively. Next thing here, so we have an examples folder, and this shows dozens of different examples of things you can do with the library in Python. So this is a great place to start, just kind of see what's possible. And notably here, we added a new wallet demo script, and this just kind of showcases most of the wallet backend wrappers that we've added. So this runs through a live demo of working with wallets, sending transactions, all kinds of different things with the wallet API. So we have a couple wallets set up here on the testnet with balances, ADA balances, so we can see transactions go through, and I'll kind of track this here. So here in Eternal Wallet, we've got it connected to the pre-prod testnet. We've got our two wallets set up, and so we'll be able to see transactions happen as they occur. So let's jump back over to the code. I've got some breakpoints set up here in the code using Python debugger, just so we can kind of stop as each thing occurs, and we can kind of talk about what's happening. So let's get that set up here. So we'll do poetry run, and then we'll do Python examples wallet demo.py. So this will run to the first breakpoint. So we've imported our two test wallets. They're in our local testnet running. And now we are at getting wallets by name. So wallets in the Cardano wallet backend can be identified either by their unique ID or a user-friendly name that you set. So we just called it test wallet 1, test wallet 2. Those are friendly names. And you can use that name to get the wallet. And what we return is an ID. So I can run wallet 1 ID here. We didn't run it yet. Continue. Wallet 1 ID. Here we go. So there's the unique ID. Wallet 2 ID. And those are used downstream for various different function wrappers to interact with the wallet. So let's go to the next one. We also get those wallets by ID. So same thing. We can rename the wallet, so that changes the user-friendly name. So we'll hit that breakpoint. Let's see. So result. Next result. Here we go. So in here will be, let's see, result.get, what is it, name. There we go. So up here we can see the first time name test wallet 1 renamed, and then it's changed back to test wallet 1. So that just shows setting it and setting it back. Next, you can change the passphrase. You have to obviously know what the passphrase was to begin with to change it. Okay, we've done that. Next, we can get the ADA and token balances of our wallets. So we are, let's continue and run through that. So here we got the balance and printed it out here. One thing to note is when you get an ADA balance, the node actually reports that in Loveless, which is the smallest possible unit of an ADA. So 1 Loveless is 1/1,000,000th of an ADA. So if you want to print a balance in ADA, you have to divide the number you get by 1,000,000. So we can see here we got our two balances, and we can see in that matches here in Eternal those two wallets. Okay, so let's move on. So we can list assets as well. We don't currently have any tokens in these wallets, so there won't be anything to report. Let's see, next. So here we get an empty list, but if you have tokens, NFTs in those wallets, those will print out here. Let's see, there's also a built-in method. So there's two different ways you can get those assets. Those are good for different things, so you can play around with that. Okay. Next we have some address utilities. This prints out the first address in the wallet. You can work with, any number of addresses in the wallet. That is a list. So we just grab the first index of that get addresses command, and that prints out there. The next section here is sending transactions. So we can estimate what the transaction fee will be for a given transaction. So you put in the details of what you're going to send, and it will print out an estimated fee. So this takes a second because it interacts with the node. Okay, here we go. So estimated transaction fee for sending 10 ADA from wallet 1 to wallet 2. And And so you get kind of a range here of what's expected. But so again, you have to divide this by 1,000,000. So you move this decimal point 6 places, and it's 0.169 ADA. Then the next section is actually sending 10 ADA. So we're doing that. This prints what the transaction ID will be, and here we're waiting for that to actually be confirmed on the blockchain. So there's a flag. So here's our send data function, and there's an optional wait boolean here. So if you set that to true, the code will block until the transaction is confirmed. So if you're running an application and an action, you needed to send data and you don't want to continue until that has gone through, set that wait to true, and then you're guaranteed that the transaction will be completed before the next function runs. So here we go. We can see here. Let's see. Transactions. Here we go. So here's the 10 ADA we just received from wallet 1 and wallet 2. That ended, printed the new balances, and we can see that. Next is an alternative method for sending transactions. So this is a more complicated interface, and this is used if you want to build complex transactions. So the Cardano node has or the wallet has a JSON endpoint that you can post to. So you can find that in the wallet documentation. Here's a simple example of again, just sending ADA from wallet 1 to wallet 2, but this can be used to actually build. You could send ADA and or tokens to multiple wallets at one time with this API. So you have a list of payments here, and this could go to many different addresses at once. So that's why you might want to use this type of endpoint. So in this example here, we construct this payload. We build a transaction from that. So let's go do that. There we go. So this prints out the JSON for a constructed transaction. So it shows where it's coming from in the wallet, the address it's going to, the UTXOs that it's selected to pull the ADA from in the wallet. Next, we'll sign that transaction. So a transaction is not valid unless it's been signed with the private key of that wallet. So we sign it. And then we can actually decode it. So if you have an already built transaction, there's a command here that you can deconstruct that and see what's actually in that transaction. And then finally, we will submit it to the blockchain. So we'll see that pop up here in a second. This one did not have a wait, so we just continue on. Okay, let's see. Next is a migration plan. So there's two commands to, if you want to send your entire ADA balance from one wallet to a new one, there's these migration functions. So the first one just prints the plan. So it'll show the UTXO makeup and how that ADA will move from one wallet to the next. And then if you actually want to execute that plan and migrate the wallets, there's another command to do that. So continue. So here's the migration plan. So it'll show there will be no leftover balance, and here's all the UTXOs that will be sent. Next, there's a couple commands for UTXO stats and snapshot of a wallet. So we'll see those here. So here's the UTXO stats. This shows the distribution of UTXOs in the wallet based on size. So here we have one UTXO with 10 ADA. We have another one with 10,000 ADA, two of those. So that just kind of builds a histogram of the size of the UTXOs in your wallet. Next is UTXO snapshot. This just shows a list of UTXO stats in the wallet. And then we can get the list of all the transactions in the wallet. So here we can see, let's scroll in here, transactions. So get transactions. You can see we have 55 total transactions in this wallet, and we just print the stats for the first transaction. And then we have some utilities about about the local nodes. So you can print the network parameters, network info, and network clock. So just a few utilities you can use. So we can see, and this, for instance, we can see if the node is synced. We can see what era we're in, that sort of thing. So network info, here we go, so sync progress. So we're in sync. We're on tip. Here's the slot number of the current tip. Here's a network info, so here's where we can see we're on the testnet. This is pre-prod, so testnet magic is 1. And then here's some info about the clock. And then we have a few utilities to work with keys of the local wallet. So we can get the account public key for our wallet. We can get policy keys, and we can create policy IDs. So policy IDs are what you use to mint tokens. So if you want to create a token, an NFT, you can create a policy ID and then mint tokens under that. So we'll just run through that quickly. So this prints these various keys, policy key. Here we're creating a new policy ID, so we could use that to mint tokens if we'd like. Next, we have some stake pool utilities. So we can list stake pools. Let's see what we got here. Continue. Okay, so we can get a list of all the stake pools. So again, this is on the testnet. We have 120 registered stake pools, and we just grabbed one from the list. So you can see their fees. This is all the metadata for the pool. See their homepage, description, that sort of thing. And then you can actually join a stake pool just from from within our Python. So here we'll pick that pool and we'll join it. There we go. That takes a little bit to take effect. We'll see if that shows up here. I'm not sure that it will. Probably don't want to wait around to wait for that, but you can join the stake pool and then you can also leave it. This will actually probably fail since we hadn't joined yet, but anyways, you can use this if you'd like. And then finally, there's an endpoint for pool maintenance actions, which is for working with your local running Cardano wallet backend. Currently, all that's supported is manually running garbage collection on the stake pools. This is not something you'd typically want to touch, but we put that there if anyone wanted it. And that's it. So that kind of runs through a high level of all the features of the Cardano wallet. So using our library, you can see very quickly get a wallet set up and actually interact with the blockchain. So you can hook this up to your application. For instance, we used Cardano-Tools to create an NFT sales platform. So we use this to work with a local wallet backend and interface with our front-end application so that we automatically receive funds and send tokens using this library. So this is a very quick way to get things up and running. So hopefully you find this useful. We'd love people to pull our library, use it, give us feedback, add features if you'd like, and just let us know how you like it overall. So I'd like to thank the Cardano community and the entire Catalyst team for supporting us and for supporting the continued development of community-created open source developer tools. These are critical to bringing new features, applications, people to the Cardano community, supporting the development environment. So again, thank you. Hope to see you in a future Catalyst Fund.